Okay, hope everyone's doing well, staying healthy, avoiding crowds and all that stuff. Um, this is the recording for the first worksheet. I'm going to be doing these recordings for you so you can um, watch them and get the most out of them and be able to do the worksheets that I'm going to give you. And you can play them over and over. I know you'll want to do that. Um, so anyway, what we're doing is switching gears a little bit. I'm not doing motor control right now. I'm going to do some tables that electricians use in the code all the time. Very common tables, and you need to know your way around them. So I'm going to look at table 31016 today. And a little thing, let's see if I can get to it. There it is. I'm going to bring up my code. There we go. And this is a 14 code, just like I do when we're in code. It's the only one I have on this laptop with the software, but these tables haven't changed, and where they do change, I'll let you know. You have the code on your iPads. It's a 17 code. You are going to go to chapter 3. It's going to be 310.15b16. Let's get this so I can view it. Single pane, actually continuous scroll. Okay, going to do a bunch of tables this week, so be good for you. I'm going to do another video on instructions on logging on and all that. Oh, it went backwards. Because I'm going to need to do attendance by you. Everything's going to be on my website too. It tells you exactly what to do there as well. Okay, here it is, 310.15b16. Right up here, it says formerly 310.16. You've probably even heard me reference it that way. It used to be 310.16 for years, like 50 years, something like that. Now it's 310.15b16, and it says allowable ampacities. That's one thing you want to remember, ampacities. What does that mean? It means current carrying capacity, ampacity. Of insulated conductors, insulated wires, rated up to and including 2,000 volts. So all the way up to 2,000 volts, some of these insulation ratings are for. The insulation ratings, there's a lot in this paragraph, so we're going to go over it. A 60 Celsius to 90 Celsius, which we're more used to Fahrenheit, so it's 140 to 194 Fahrenheit. All insulations have a temperature rating where they will start to degrade if internal temperature from the current going through the wires and your external temperatures, like your surrounding temperature, by the way, it's called ambient temperature. If it reaches to this point, the maximum on the value of the insulation, it will start to degrade over time, and then it will dry up, and then you have a problem where if it dries up and cracks, you will have short circuits. So it's important to pay attention to insulation ratings. This particular table is specifically for not more than 3 current carrying conductors. That's not including the ground. The ground is not current carrying unless there's a problem. It says in raceway cable or earth directly buried. So not more than 3, so up to 3, including the ground, not including the ground, in a raceway cable or earth. Sometimes specific wires, usually they're in raceways or cables, but there is a way that you can also bury certain wires directly in earth that are rated for that. And if they're bound together, if there's more than 3, we have to do something different. Basically, it says not more than 3 because as you send current through more than 3 conductors, you get internal heating. And then you have to do something different, which we're also going to learn about this week with another table. Based on ambient temperature. Ambient, what is that? That's our surrounding temperature. Surrounding temperature around your raceways. So like if you were, this is a normal installation of about 86 Fahrenheit. If you were higher than that, there's also a table we're going to look at this week on how we would have to take down the value of these conductors. Many areas are higher than 86 Fahrenheit. Air-conditioned office buildings are not, they're not higher. Our shop is, right? Also, like if you were wiring in a boiler room or a rooftop or something like that, it would all be above 86 and would have to use this table and use one other table with it, which you're going to learn about this week. Some other things about this table I want to point out are, first thing is temperature rating of conductors. And that goes through this whole part right here. It's all different ratings where it says 60 Celsius, 140 Fahrenheit. That's all of these, the TW and UFs. We're not installing those these days. That's because we could come across old wiring and we might have to work with it, so we have to know what it is. As well as a 75-degree column, our new wires are, I can't highlight them all, but all of them in this column here, this section, these are also older conductors. Most of our new conductors these days are 90 Celsius. And you'll see that that includes our THHM, which we're very used to, and all these other types as well. THHW is similar to THHN, except it's rated for wet locations. Actually, both of these two together, a lot of THHN these days is also rated THHW, like it's combo type thing. Not all of it though. But this is 90 degrees Celsius, insulation 194 Fahrenheit. Breaks it down to a couple of different types of conductors. This copper section takes this whole half of it right here. That's copper conductors. Aluminum or copper clad aluminum, that's something different. Aluminum is just straight aluminum conductors, also insulated of course, but copper clad aluminum is where your outside layer of the conductor is copper, and then internally the core of it is aluminum, and it's metallurgically bonded together, and that's what this section is also including, aluminum and copper clad aluminum. You'll see that the amperage ratings are taken down for this. I think I already talked about ampacity. Ampacity is a combination of the two words amps and current carrying capacity. So the ampacity of these comes down with these. With this, it's not as good a conductor as copper. Then it gets into sizes right here. Size AWG or KC mil. KC mil is 1,000 circular mil. AWG is American wire gauge. American wire gauge, those conductors are 18 down to 4/0. So those are all American wire gauge conductors. The way these go is 18, as you probably know, is smaller conductors. That was the conductors you did when you did the bell jobs in 9th grade. It was 18.2, 18.3. 4/0 is larger. It's about the size of my finger, to give you a reference. So it goes from this actually larger number to a smaller number. But the larger number here is actually a smaller wire. The small number here is a larger wire. What aught is like, just the term aught is like a zero term. So it goes down to 1, then it goes 1, 0, 2, 0, 3, 0, 4, 0. Then it starts to go to what we call KC mil, 1,000 circular mils. 250 right here all the way down to 2,000. So 2,000 out of this whole chart is our largest conductor. 18 is our smallest. You'll find that's going to be on the worksheet. 2,000 is very big. Most I've worked with as far as the largest was 500s, and that was about the diameter of a quarter. 2,000 is a lot larger. It's not as common to work with those with 2000, more often we do something called paralleling conductors, which we can get into at a later time. So those are all your sizes right there. These are ampacities, current capacities. For example, if I take a number 6 conductor right here, why I brought that up. All right, 6. Looks like I can't. There we go, 6. If I was to do THHN, which is this column, the 90-degree column, follow it down, we see that size 6 conductor is good for, if I can highlight this, looks like I can't. Can you see my cursor right here? 75 amps. So you would know that's good for 75 amps. So depending upon the equipment you're wiring, that's what you'd use. Let's look at one we're familiar with, 14 gauge right here. And we're going to talk about these asterisks in a minute. 14 gauge is actually good for 25 amps, as you can see right there. We only put it on a 15 amp breaker, and part of that is because of these asterisks. They explain that. It gives you a little bit extra because just in case we have certain conditions where we have to do something called derating, take down the value of the conductors because of external situations or because of grouping too many conductors. So it gives you a little bit of a buffer. You might be familiar with 12s right here. That's rated at 30. However, a 12 can go on a largest breaker size of 20 amp and a 14 of 15 amp. And we'll look at that too shortly. That's what these asterisks here are for. If you carry these over, for example, the 6 I looked at was 75 for THHN. That was 6 copper. Let's look at 6 aluminum or copper clad. We're over here on this side. I can't highlight it individually, but I think you can see my cursor. It's 55 amps. So it's less value. Aluminum is not as good a conductor, and copper clad aluminum, they're not as good conductors as copper, so the value is less. But there is I think there is, not common that yeah, there we go, THHN, aluminum, right here. XHHW is very common for service conductors, aluminum. And there's our values right there. More often, the conductors you use and size out, you're going to use a 90-degree column. And sometimes, for certain reasons, we'll do the 75 as well, if our lugs are only rated for that, which we'll get into at another time. Okay, so that should help you. So if I would ask you what is the amperage rating of 1/0 copper type TW insulation, you'd go over here to 1/0, you'd cross-reference with TW, and you'd see that it's 125. That's the amperage, current capacity, ampacity, in other words. So hopefully that helps. That's making some sense. You can email me or post questions to Shobi. Let's look at a couple things here. It's talking about with one asterisk is there's going to be ampacity correction factors that we're going to look at. This table here, 31015B2, and there's also one other table, B3, that we're going to look at. This one here is specifically talking about ambient temperature, surrounding temperature. If it's hotter, we're going to learn how to work with that this week too. 244D, this article 240 is overcurrent protection. So in other words, your circuit breakers and fuses. It says to refer to this for conductor overcurrent protection limitations. So on these ones up here, these smaller conductors, it says we refer to them. So let's do that. 244D. So chapter 2, that's the way the code works. If it says 240, it's going to be chapter 2. 240, overcurrent protection. Then we come down to 4, protection of conductors. And it talks about how your conductors, other than flexible cords, cables, fixture wires, shall be protected, I can make this bigger, against overcurrent in accordance with their ampacities, current capacities, specified in 310.15 unless otherwise permitted or required in 244A through G. So it says you could protect your conductors according to their ampacities in the table we just looked at unless otherwise permitted or required in this table here. And this does get into some specifics with where we, like you remember our 14 gauge I think was rated at 25 amps. We can't put that under a 25 amp breaker. We just follow this down, 244, and we're going to look at D. So I'm going to go to the next page. Small conductors. Unless specifically permitted in 240 E through G, the overcurrent protection shall not exceed that required by D1 through D7 after any correction factors for ambient temperature and number of conductors have been applied. So it's saying this is the size you have to go with when you're dealing with overcurrent protection, the breaker, the size breaker you put these conductors on. So in this case here, comes down 14 AWG copper as you're used to, 15 amps, right? That makes sense. Even though it's rated 25, you only can put it under a 15 amp breaker. 12 AWG aluminum or copper clad, 15, very rare, you're not going to really see that. But here you go, 12 AWG copper, 20 amps. So that's why copper, 12 copper THHN, even though it's rated 30, it can only go under a 20 amp breaker. Again, it's a little bit of a buffer so that when we do the things we're going to learn about in the next few days, the D rating, the taking down the value because more than 3 conductors or surrounding temperatures a lot to protect our insulation. It gives us more to start with so that when we're done derating, we're not below 20. 10, 30 amps. You might want to pay attention to those for the worksheet you're going to do. This is very important for that. All right, let me go back. Again, this was 240 4D. And we're going to go back. 310.16. And I think I've pretty much covered what I want to cover. But let's just double check. This is one that we're going to look at in the coming days. Ambient temperature correction factors based on 86 Fahrenheit. We're going to learn how to do that. And this is the other one we're going to look at. And adjustment factors for more than 3 current conductors in a raceway or cable. When we have 4 to 6, we have to take the value, ampacity value at 80%. We'll get into how to do that. All right, so again, I think we pretty much covered everything on this table. Very useful table. Electricians always are referring to this table. All the little like small booklets, the kind of cheat sheets for electricians that you keep maybe in your toolbox or whatever. Usually this table is always in that. There's a good set of books out there called Ugley's Electrical References. Yep, Ugley's. And that has a lot of these tables in it too. All right, so again, post to Shelby. We're going to do our posting as far as being here and questions on. I usually had you post like those questions on the shop project folder on Shelby. We're going to do it on the written assignments because these are going to be all written assignments. You're not going to be building physical projects. So every day you have to post there and say that you are here. And it gives me a timestamp. And I need to know that you've logged in and you've checked in. And I also need you to just ask me any questions there as well. Or you can email me my email, which is on the website as well. So I haven't posted the website yet, the weekly announcement, but I'm going to post that shortly. I'm going to create a link to this right on it, but I won't have a link to all of the recordings yet because I haven't done all of them yet. All right, well, that being said, stay safe, Stay out of crowds, and hopefully we'll see you all soon. If I can figure out how to shut this down. Bring up that. All right. See you soon.